All right, fun times all around here at UL Lafayette. Today we're going to do a section on Booleans, especially Boolean solids, go over the Boolean menus, how to import an image and use that as an underlay, how to autosave your work just in case you have a crash, even though Rhino is pretty good about giving you a recovery file, and smash and unroll. Kind of a little diverse menu of things today, but I think it'll be fun for everyone involved. So if I want to make an eyeball, I'm going to start with the sphere, right? Let me get a little rendered view or shaded view. But I want to have like an inset, a spherical inset. So you have something that's convex and concave. So I'm going to use one object to Boolean another. This shouldn't be all that new to y'all. I'm going to do Boolean difference. One I want to keep, one I want to get rid of. There we go. Whoa. So that's almost like an eye. We have our cornea established. And I'm going to use this sphere on the inside. And this is where the 4 views comes in handy. I can adjust. All right. So now I want to add this. So I'm going to Boolean union everything I want to put together. There we go. And as you can see in the wire, let's go to a ghosted view instead. Maybe an X-ray might be even better. No, ghosted. This is just, it's still one solid. It's a poly surface, but all the geometry I had on the inside is now gone. So I want to put a little bit of a recess into this cornea spot. I'll use a command we used a long time ago. There we go. See if it'll let me project this on the surface. And it did nothing. Let's try this again. It's weird, didn't move anything. And what is that and where did it come from? All right, so in the front view, we're going to repeat the command. These curves, this surface. Interesting. Still not what I wanted. Let's try pullback. This surface. Go for it. All right. Not exactly what I wanted, but I'm kind of tired of fighting with it. I want to loft these two. Go for it. All right. I'm going to extrude this surface. Solid extrude surface. All right. Redo my direction. There we go. So this is going to let me adjust how deep into this area I want to remove from. Boolean difference. What I want to keep. What I want to get rid of. And get rid of that surface. And there I have an inset. Rendered. Interesting, yes, yes. All right, so I could print this because I really haven't. Yes, it is a poly surface, but all I've done is Boolean union or Boolean difference. If you just keep in the Booleans without really messing with the surface, it should stay printable. Now I'm going to give you a little warning. Booleans like to have a little bit of overlap. I'm going to give me a 9 by 9 by 9. And I'm going to copy that one. Copy, paste. And I'm going to intentionally move this straight in here. There we go. So I have surfaces that overlap each other. Now, it might Boolean union, it might not. Let's see what it does for me. And it does, but just a word of warning, when you have surfaces overlapping each surfaces on themselves, it's going to give you some trouble. If I give it a little extra area on the sides, make sure I got a good offset. I'm not worried about this Boolean unioning or Boolean differencing at all. To a difference. I want to keep this one, get rid of this one. There we go. So if you start to think of things in unioning and differencing, you're able to create objects faster than just create them by solids or curves outright. Boolean intersection. Good question. Let's have a fun intersection. Just give me something respectable, thank you. Copy, paste. And with our rotate, just to add some interest. There we go. So if I want the combination of the intersection of these two, so whatever that shape is, Boolean intersection. I messed up. Try again. First one, second one, output gives me this guy. Interesting shape. Boolean split and Boolean two objects. When I don't know exactly the output that I want, I'll go to this one. So let us make another solid in a quick manner. Sure, let's just integrate this in here. Why not? And I want to throw a cube out. Rotate a little bit. This is 245. And I just want a corner sitting on this. No. All right, so this will work. If I don't know what I want, I can do Boolean two objects. That's Boolean split. Let's split these two with this guy. Mess that up. Split this one. Nope, it did work. Sorry, let me redo that one. All right, so these are three individual surfaces. Boolean split. Split this object with this object. And there we go. I still have the inputs though. Like with Boolean difference, it'll take one of the inputs away. But Boolean split and Boolean two objects gives you more options. That's why I like using the split command, even with the curved, the surfaces, more than I like the trim command. All right, so let's do Boolean 2. I don't like the way they set this up. It requires me to right click, and I'm so used to left clicking. So now if I right click Boolean two objects, just select two objects, and then I can click through until I get the output that I want. And I want to get it ghosted so see what's going on the inside. So intersection, difference, difference, split. Pretty stinking helpful. Anything else? Variable radius chamfer. We're going to do these. I've had lots of issues from students over the years about how doing a fillet edge or a blend or a chamfer doesn't work, variable radius is probably one of the best ways to solve that. Cat planar holes, y'all know how to do that. Extract surface, you could explode, copy, paste. Merge two faces, never used it before. But y'all know this, just as a quick reminder. Once you put two solids together, it's solid, but it's also a poly surface. So your ability to rebuild it stops when you hit the Boolean difference or join or split. We've done the rebuild command so much, y'all should know how to change these at the drop of a hat. Let's say I wanted to create an organic object from like either a drawing that I've done or a vector image or a photograph. I would like to import some type of drawing, so instead of having to refer back and forth, I can just draw on top. This is how you go about doing that. Go to Edit. No, sorry, it's View. Background Bitmap. And I've placed together a side view and a front view of a dunny. Let's pull in the side view. It's going to let me define how big it is. I want to keep it at the same. It would be great to put these at the same height. I should have went ahead and did that in Photoshop. And so if that's my front view, I can come in here and do my side view. View, background bitmap. Cool. In all honesty, I really do want these to be the same size when I put them down and have like the same origin. That way when I start building a surface on one, I don't have to come back and move it for another. So this won't save me time, but you'll get the idea. Give me that non-uniform scale. There. Scoot that up a bit, and it is kind of oblong. Nope, too big. Just knock it down an inch. Let's see, do I want to... I could do a curve and do a profile and do a sweep. But in this case, I think I'm gonna do a blend surface. I'm gonna put a sphere at the top. Cut it. So extrude this guy through. And I'm gonna need to make a void over here. So I'm gonna use the same guy. Copy, paste. Not as much. Let me do the split first. Split this object with the plane. Delete. Delete. And let's look if I need to push this farther. What I want to keep, get rid of. Need a little bit more. And this time I use split. Split with this, with this. All right, I think that looks good. Let's do blend surface. Give me a little preview. Now, why in the world do I have a twist? Let's redo this and see. I do not know why it's doing that. Maybe the starting point's off. Or maybe they're spinning in the wrong direction. Y'all see that? Yeah. This one's spinning to the left, this one's spinning to the right. We're going to flip one of them. I feel like I'm getting there, but I don't know why. All right, that was really difficult and shouldn't have been. All right, so that's taken care of. This body has like a weird shape to it and kind of an awkward neck. We'll come back and work on the neck in a second. Just give me a one-dimensional. All right, so let's rotate just a smidge. There we go. And let's input this width. All right. Now I can keep on moving it, or I can come in here and rebuild. Let's get these down to like 12. Let's lower these just a little bit. Get a little hiccup. Same thing in the back. All right, looks good. All right, so I got a predicament. I want to put this over here, but I don't want to have to rebuild the entire thing. Yes, I can mirror, but I want this exact hole on the opposite side. How can I do that without? There you go. It's a symmetric object, so if I want to come in here with a plane, put it dead center. Now I can.
Does that not work because the ear is kind of to the front of one side? Oh, no, no.
I believe it'll work. So we'll split. Yeah. There's already a poly surface anyways once I attached it. So all my editing capabilities are kind of out the window. There we go. Good call. I want to make some feet. I'm going to leave the hands out just for the sake of time. I could probably, yeah, I'm willing to do a blend so I can get that to go in nicely. So that wide. And I'm just going to rotate it. Put it center. This is interesting because I know it's not going to be a circle here. More like you took a circle and crush the top and bottom towards each other.
Cylinder.
Not quite a cylinder. Let's see if I can quickly do what I'm thinking about. That's what I imagine it's going to look like. Let me extrude this. Can I get a cap, please? Thank you. And I'm going to put this so I can do a split and use blend surface. All right. No, not quite into the body cavity yet. I'm going to make it just a hair smaller. Everybody got a good spot? Almost there. All right, that'll work. Let's just use a normal split. Split this object with this one. Get rid of that. And I want to do a planar surface just to fill this guy in. There we go. Freebie. Blend surf. This is just not being friendly towards me today. Okay. Not perfect, but I think you get the idea. So I do the same thing as I did just a second ago for the head. If it's all a poly surface, I can't adjust it. So if it's symmetric, I might as well split and take advantage of the work I've already done. And I want that to be perfect. So we come back to the move command and more of a practical application. That corner to the center point, and then I'll just reposition. So now I know it's cutting it where I cut earlier. Split this object. That plane, delete, delete, will take you and mirror back. There we go. If I want to, I can join these back up. And just clarity on definitions, joining puts surfaces back together, and Boolean combines solids together. And after you're done using your, what things these called, background bitmaps, you can remove them in case they get in the way. Very well. So let's say I was working on this and I left and something in my computer glitched. If this took me 2 hours, I'd be furious. If it took me 6 hours, I would just be in the mood to quit. Here's a little, I don't know if the Rhino 5 has it. I imagine it does. My old Mac, which isn't up to date, won't let me do this. But you can set increments within Rhino to remind you to save. It's either in properties or options. Here we go. Rhino options, you can get there through here. You can get there through tools, options, or in the way that I got there originally, properties. Go down here, Rhino options, files. And so autosave says every 20 minutes, I'm gonna do a save for you whether you like it or not. So hopefully this will, you can do every minute, but you're not gonna be very productive. What do you mean?
It doesn't like automatically save it while you're still working on it?
Yes, it will save, but if we're going to a big file and it takes 15 seconds to save, and you're saving every minute, you're kind of being counterproductive. If you want to offset some of that frustration, that will be your friend. Let's say I want to print this guy out, but I don't have a 3D printer and I don't have a router. Or if you want to do something that has some complex geometry to it and you have a laser cutter or some scissors, you're in luck because of the smash command. I'm going to go ahead and explode it and get rid of this bottom part. Hide you for a minute. So I have a cone and I have a printer, but how I want to make this in 3D space without doing some complex math, which most designers aren't great at math. You can do it like this. Select your object, unroll, developable surface, or smash. They do a lot of the same thing. There we go. So it took my 3D object, smashed it. So if I take this to Illustrator or just print this straight out, cut, roll it up. It doesn't have the tabs. You have to add the tabs in manually, but that helps a lot. So let's increase the difficulty. I want something close to a cube protruding out. A little bit smaller. So let's Boolean difference. One I want to keep, one I want to get rid of. Now I got a lovely inset. Will it allow me to smash it? Yes, it will.
Sometimes it won't let you.
It will. So if I make this shape, all I do is add tabs to these and then I'm in business. I know what you're thinking. Wouldn't it be great if we could do that to a torus? It would automatically tell me how to print this out and roll it back together. Now, unrolling doubly curved surfaces will produce inaccurate results, and it's not willing to do it. So if you want to have a sphere or a torus, good luck. But I could come over here and change my NURB to a mesh. Kind of make it like something you know from N64. Let's just keep a few ones. There we go. And from this one, I can do mesh to NURBs. There you are. And now I can do smash on something that's not quite a... Sorry, got lost. So if you take all these pieces and put them together, you have something resembling a torus. All right, I think that concludes us for today as far as the... Do I want to put a robotic eye on a dummy? Of course I do. I can't turn on poly surfaces, but I really want to edit this surface, so I'm going to explode it. Turn my control points on. I'm not getting enough, so I'm going to select this half and this half. Rebuild. Points. There we go. And I want to gotta be careful about that one right there. How do I look to a front view? I don't want those, don't want those. And I lost them. It happens sometimes. And a little face droop here. Man, you see what happened? It clicked on something like either near a point or some type of intersection. Gotta go back and fix it. Drop down, move back, robotic eyeball. Yeah, it's pretty creepy. Points off. And I'm going to quickly borrow one of these. Scale it down. I'm going to cap this. I really want to finish this out before we leave today. Cap planar holes. Unable to cap. That's okay, because I don't want to do patch though. Because I'm afraid if it doesn't patch right, it won't be sealed. Can I at least join y'all? Would that be okay? Man. I know why, and this is going to be a really good learning point. So I want to join these two. I want to make it a solid, and even if I put a cap, like if I come in here and manually put a cap on here, like I showed y'all how to do earlier, it won't put a cap on something that's not straight. All the way across. Old school Boolean split or Boolean difference, Boolean union. I'm going to split this guy with this guy, repeat this guy with this guy. Come on. Here. Good. Delete the things I don't want. Join the things I do. And of course, it should work, right? I should be able to cap these. I should be able to join these. Why won't it join? This is why. Come in here. Delete this for reference. Okay. I have a solid here. And I have a solid here. I have two walls that are hindering it from being a closed object. So if I want to make this guy, it's like I've got to take out these walls that are in the way. I told you earlier, if you have surfaces on top of surfaces, it's not going to want to Boolean union, which is what I'm wanting to do in a way. All right, so explode these, delete, delete, and how do I get it back to where I was without pulling my hair out? Move command, good. There. Nope. There we go. So will let me join. It will let me join. Hooray. So now I have a solid once again, and I can print this without troubles. Quick taper. Taking a while. Little bend. It's a wee bit further, please. Seems my taper went a little crazy. And that's why this one has so many control points that it's turned black. Oh my goodness. If your surface is turned black, you've done something wrong. Taper really likes being on the origin, so I don't mind helping it out with that. All right, try this again. Taper object. What do I have here? Curve doesn't matter. Taper axis. Really? I'd just rather not taper at this point. Put a bend. And if I just want to bend this top section, man, this doesn't like me. Yeah, at this point, explode. Like, I'm really running the risk of my computer shutting down. And I don't know why it's gone so complicated. Edit, rebuild. I don't need that many control points. Is this even close? All right, I'll do 35 and 35. All right, thank you. Will you join back up for me, please? Can you join up for me? Would that be okay? Sweet, all right. We'll rotate. That's sufficient, and then it has a little cutout on its hand. Very well. I'm going to do a Boolean difference after I make this into a solid. Cool. What I want to keep, what I want to get rid of. And I'm curious to know what type of radius to edge it will allow me to use. 1. How we look? Probably too much. Yep. Repeat, 0.25. Still too much, 0.1. If this doesn't work, we're leaving it alone because it's kind of irrelevant at this point. Yay, all right.